Students, we'll discuss the moving charges and magnetism. It's a very important chapter, very interesting also. Now we'll discuss the concept of the magnetic field. See what is the magnetic field, because this unit is related to the magnetism, so you should know the basic concept of the magnetic field. Actually, magnetic field means, suppose you are taking a magnet N to S, so there is an effective field. There is an effective field around a magnet in which if any other charged particle or magnet enters, it experiences a force. So this effective field around a magnet is called the magnetic field of that magnet. So simply we say the region near a magnet, it is the region it is a region near the magnet. Okay, so it is the effective region, you can say. Now, to see the clear effect of the magnetic field, Oersted explained first time how electric current produces the magnetic field. So we'll discuss a very important concept, that is the Oersted's experiment. Okay, it is in class 10th also. Let me remind through this topic. Suppose this is a wire AB and it is connected to a cell and the battery, key, etc. When current, and suppose a magnetic compass placed just below this wire AB conductor. Okay, so when current flows, suppose current flows are from positive to negative. So when current flows through this conductor, the magnetic compass shows the deflection in one direction. Okay, and to confirm that this deflection, because this is a magnetic compass and it will deflect only and only in the presence of the magnetic field. It means the current is producing here the magnetic field around this conductor. Now, to confirm that actually this current is producing the magnetic field, if we reverse the direction of current, or by interchanging the polarity of the cell. Now suppose the polarity is like this, negative, positive. So in this case current will pass from positive to negative like this. Okay, and we observe that in that case, you can see clearly it is in the first case. Now by interchanging the polarity, direction of the current is changed, and we also see the deflection of the current, deflection in the magnetic compass also changed. Okay, so it confirms that electric current produces magnetic field around a conductor. Simply you can say current carrying conductor produces magnetic field around it. Okay, this is the gist of the Oersted experiment. Now it was again explained with more new points, that is how can we find the magnetic field due to a current carrying conductor. It was explained by the Biot Savart. So we'll discuss, see what is the Biot Savart. So that is very important for your exam, Biot Savart's law. Okay, Biot Savart's law. Biot Savart's law told about the magnetic field produced due to the current carrying wire. So Oersted explained about it. Now suppose the magnetic field is produced around this current carrying wire. We don't know what is the length. It is an infinite length. Okay, so we are taking the small length. So, and take the small element, that is say the DL. Okay, say the DL, small current element, okay, through which the current is passing. So Biot Savart told that is at point P in the region of the magnetic field which is produced due to this wire. So according to him, you can see it is a point P which is in the region of the magnetic field which is produced by this current carrying wire. So what is the magnetic field intensity at point P due to this small current element DL? Okay, so we write also it is like the IDL, that is the current element. It is a vector quantity and its direction is always in the direction of the current. Okay, it is a vector quantity, it is the current element. Okay, so now he given a rule, a law. Suppose this is a distance r, this is a distance r, say it is a position vector r. So according to Biot Savart, Biot Savart observed that, and he's given the rule, that is the dB is directly proportional to I dl cross r, okay, upon r cube. Okay, according to Biot Savart's law. Clear? dB, that is the small magnetic field produced due to the small current element IDL. It is the cross product of DL and R upon R cube. Okay, or dB is equal to mu naught upon 4 pi I dl cross R upon R cube. This is the law. And mu naught here, mu naught upon 4 pi it is a dimensional less proportionality constant, and mu naught is known as the permeability of free space. It is the permeability of the free space, and the value of the mu naught upon 4 pi, it is always equal to the 10 to power minus 7, and I am writing the unit also, Tesla meter per ampere. You should know the unit of the magnetic field. It is Newton per ampere per meter. Okay, Newton will discuss from where it comes. So Newton per ampere per meter, and its unit is also Tesla, and its another unit is Weber per meter square. Okay, these are the units. So you can find the unit of this using this concept. So its unit will find the Tesla meter per ampere. Okay, so this is the unit. It is the unit of B. So from this relation, it is very much clear that the magnetic field intensity at any point which is at distance r is always directly proportional to I, always directly proportional to the dl, and it is inversely proportional to the square of the distance. So this is about the Biot Savart's law. So just remember, it is the formula, and you have to remember this formula clearly. Now see dimensions. What is the dimension of the mu naught? Okay, important for your exam. Dimension of mu naught. So I'm writing directly. It is because the mu naught is the Newton, its unit is the Newton per ampere square. Okay, Newton per ampere square. So we can write Newton means mLt minus 2, unit of the force, and the ampere square. Okay, ampere square, a square. So its dimension formula is mLt minus 2 a to the power minus 2. Okay, so this is the dimension of mu naught. Okay, I think it's clear. Now we can find a relation between the mu naught and the epsilon naught also. In the first chapter you have studied about the epsilon naught. Now we'll find a relation between them. Okay, so relation between mu naught and epsilon naught. Okay, see what is the relation between them. You know very well mu naught upon 4 pi is equal to 10 to power minus 7 Newton per ampere square. Okay, clear? And the epsilon naught, you know very well, it is equal to 1 upon 4 pi epsilon naught. If you try to remind its value, it is 9 into 10 to power 9, and the unit, can you remember, it is the Newton meter square per Coulomb square. Okay, just see the last chapter, first chapter of this 12th class. Now we have to find a relation between the mu naught and the epsilon naught. So here we can find a relation because the values are here written, so that's why I am not starting the new page, otherwise it will be difficult to understand you. So mu naught epsilon naught is equal to, now I'm writing the values. Mu naught, that is the 1 upon 10 to power minus 7 is the unit value of the mu naught. Mu naught yes, 10 to power minus 7 and 9 into 10 to power 16. Okay, its value is epsilon naught, your value is here, you can see here epsilon naught unit. Okay, just if it is not clear, I am writing again. See here, from here mu naught, what is the mu naught? Mu naught is here 4 pi into 10 to power minus 7 from here. Okay, and from here epsilon naught is equal to 1 upon 4 pi 9 into 10 to power 9. Is it clear? From here is it clear? So 4 pi is cancelled, so you can write 10 to power minus 7 upon 9 into 10 to power 9. So it means mu naught epsilon naught is equal to 1 upon 9 into 7 plus 9, that is the 16, 10 to power 16. Is it clear? Or you can write it is 1 upon 3 into 10 to power 8 square. Okay, and what is the value, what is this 3 into 10 to power 8? It is the speed of the light in vacuum, so it is 1 upon c square. It is the 1 upon c square. So what you found here, it means c is equal to 1 upon mu naught epsilon naught, take the under root. Okay, so this is the relation between the epsilon naught, mu naught with the c, that is the c is the speed of light. Okay, if you put the units of both, you will find the unit of c also, that is the meter per second, which is the speed. Now we can compare the Coulombs law and the Biot Savart law also. Okay, we can compare. Now comparison. So comparison comparison of Coulombs law, Coulombs law and Biot Savart law. Okay, here in bio T is silent. Okay, so you will pronunciate Biot Savart's law. Okay, like this. So Coulomb's law says a small electric field intensity due to small charge is given by 1 upon 4 pi epsilon naught dq upon r square, and the Biot Savart law says dB is equal to mu naught upon 4 pi I dl sine theta upon r square. Okay, because it was the cross product, na, I cross, so you can write the ideal sine theta upon r square. If you compare the both, what you will find here, you can see first similarity is that both obeys, okay, both obey inverse square law, okay, this is the main thing. And second thing, dq is a scalar quantity, but it is a vector quantity. Okay, ideal, it is a vector quantity. So dE or E depends on a scalar quantity, but B depends on a vector quantity. Okay, vector quantity. Clear? And here you can see, suppose this is a charge q1, this is the charge q2. So electric field is always along the line of joining, but the magnetic field is always perpendicular. This is the point P, so this is always perpendicular, not along the line. Okay, so another difference, E always along the line, joining the charges. Okay, joining the charges, but magnetic field, that is the B, is always perpendicular to the line joining. Okay, this is the another difference. And the one more thing, E does not depend on angle, but B depend on angle. Okay, because theta is here. Theta is the angle between DL and line joining. DL and line joining the point to determine B. Okay, to determine B. Okay, suppose this is the wire, so this angle is theta, this is the R. Okay, this is the DL, so this angle is the theta, this is the point P, so this is the angle between the DL and the line joining. So it depends on the angle also. So this is about the Biot Savart's law. Now in next video we'll discuss some important uh, applications of the Biot's law. Thank you.